Lesson 15, CMOS Logic Gates. Section 15.2. Discrete Circuit, NOT. Experiment 15.2.1. Pause the video, and follow the instructions. This is the same experiment as experiment 15.1, except that the gate is constructed using discrete elements. TR1, whose model number is ZVP2106A, is a P-channel MOSFET, and TR2, 2N7000, is an N-channel MOSFET. The reason these MOSFETs are used is that they are easily available from an internet shop in Japan. These are the results. The top graph shows the waveforms of Vx and Vy. The bottom graph shows the Vy versus Vx characteristic. The threshold voltage of the experimental circuit was approximately 2 volts. When Vx is lower than Vth, TR1 is turned on, and TR2 is turned off, resulting in Vy equals the DC source voltage VCC. When Vx is higher than Vth, TR1 is turned off, and TR2 is turned on, resulting in Vy equals 0. The upper transistor is a P-channel MOSFET, also known as PMOS, and the lower transistor is an N-channel MOSFET, also known as NMOS. The MOSFET fabrication process that uses complementary and symmetric pairs of MOSFETs is called CMOS. CMOS logic gate is a logic gate produced through this process. One of the important characteristics of CMOS devices is low static power consumption. Since one of the two MOSFETs is always off, except at the moment of switching, the MOSFET pair does not draw any power from the DC source. Experiment 15.2.2. Pause the video, and follow the instructions. This is to measure IS versus VGS characteristic of PMOS. This is the obtained IS versus VGS curve. If VGS is lower than -2.8 volts, then IS flows. This is a typical enhancement type PMOS characteristic. The horizontal axis is replaced with VGG. Then we have this IS versus VGG curve. It is found that if VGG is lower than 2.2 volts, then IS flows. The ID versus VGG characteristic of NMOS, measured in experiment 8.3.1, is superimposed. There is a region around VGG equals 2 volts, where both IS and ID can flow. Experiment 15.2.3. Pause the video, and follow the instructions. This is to measure the current I2 that flows through both TR1 and TR2 around VGG equals 2 volts. This is the obtained I2 versus VGG curve. When VGG is changing from high to low or vice versa, that is TR1 and TR2 are turning on or off, I2 flows for a short moment, and the MOSFET pair consumes a small amount of power. Section 15.3. Discrete Circuit, NAND. Experiment 15.3. Pause the video, and follow the instructions. This is to test a NAND circuit that consists of discrete elements. TR1 and TR2 are PMOS, and TR3 and TR4 are NMOS. These are the measured waveforms. When both Vx0 and Vx1 were high, Vy was low. The circuit functioned as a NAND gate. This is a timing diagram of NAND gate. When both Vx0 and Vx1 are low, TR1 and TR2 are turned on, and Vy is high. Pause the video, and check the combinations of transistors being on and off. Exercise 15.3. This is your homework. Design a CMOS NOR gate, using 2 PMOS and 2 NMOS. Section 15.4. Discrete circuit, N. Experiment 15.4. Pause the video, and follow the instructions. This is to test an NAND circuit, which is a series connection of a NAND circuit and a NOT circuit. These are the measured waveforms. When both Vx0 and Vx1 were high, Vy was high. The circuit functioned as an NAND gate. Exercise 15.4. This is your homework. Design a CMOS OR gate using 3 PMOS and 3 NMOS. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.